Okay, this is Mr. Coombe. How are you? Let's do some mass-to-mass calculations here. Mass-to-mass stoichiometry. So we have a problem. We have 100 grams of table salt, and we completely dissolve it in a colorless solution, and then suddenly a white solid starts to form. We want to know what this white solid is and how much of it forms. So pause this video right now and see if you can figure out what it is. I'll give you a clue. It's a precipitation reaction. So have a look at a data sheet showing solubilities of different types of ionic compounds. So pause this and I'll see you in a second. Alright, welcome back. So let's first have a look. Table salt, we know table salt is pretty easy. Table salt is just sodium chloride. Okay, it's pretty easy, sodium chloride, and that's going to be dissolved, so it's in aqueous solution because we completely dissolve 100 grams of it, and we're going to add that to some colorless solution. That colorless solution, I don't know if you figured it out, but if you figured it out already, that colorless solution is silver nitrate. Okay, silver nitrate. And once again, because it's dissolved in water, it's going to be aqueous. That's AQ. I apologize for the horrible handwriting. So we react those two. When those two are in solution, this is a double displacement reaction, or actually a precipitation reaction. So let's have a look what it actually forms. It's going to end up forming silver. So the actual solid that forms, and you'll notice that the silver will join onto the chlorine ions and will form silver chloride. So, and that's our precipitate. So we have a solid, and it's going to form sodium nitrate. Add that to sodium, and let's put our nitrate in green. Nitrate. And that's aqueous, because these two, the sodium and the nitrate, we call them spectator ions. They don't actually, they're not actually involved in the reaction. The only ones that are involved are the silver ions, so silver plus, 1 plus, and chlorine 1 negative. When they get together in a solution, they form a solid silver chloride. So now let's do our actual equation. So let's first start off with our mass out of our sodium chloride, our table salt. So we started off with 100 grams of that, 100 grams of our table salt. So then let's have a look at the molar mass of table salt. Molar mass of table salt would just be literally how much each atom weighs. So we have 1 atom of sodium and 1 atom of chlorine. So remember that 1 mole is just a quantity, just like a baker's dozen. Baker's dozen is 13, or just a dozen is 12. So if you have 2 dozen, then you have 24. Okay. Let's find out how much one of those units actually weighs. Now, if you use your periodic table, you should be able to figure it out. So it's the atomic mass of an atom is actually how much 1 mole of those atoms weigh. So if you look on a periodic table, any periodic table, especially for the Western Australian Year 10s, the data sheet that you get, you'll need the molar mass, and let's put this in white. So it'll be the molar mass of sodium plus the molar mass of chlorine. Now, in any exam, you shouldn't have to do this part. You should already go to the addition of these two, but I'm doing it the long way so that you see how it's actually done. Okay, the molar mass of just a mole of sodium is 22.99, and that's in grams for every mole. That means grams per mole. And sodium should be, chlorine, apologize. Chlorine should be around about 35.45. 35.45 grams per mole. And if you add those two together, I believe I have it somewhere here, it should be about, let me put it in let's keep it in purple, so it's 58.44 grams per mole. Now it's important that whenever you're doing any kind of calculation that you put these values in, you put these actual final units in. Now in our reaction, before any of this starts off, we're actually quite lucky that this reaction is already balanced. But it's really, really important for the next part that you balance this equation, right? If there's no number in front of the actual compounds, we can assume that that is a 1, and that is a 1, that is a 1, and that is a 1. Now that's not always going to be the case. It's not always going to be all 1. Sometimes there might be different numbers. Okay? So here, now we've got to find out how much, how many moles of table salt we have. So number of moles of table salt, sodium chloride. I think that's a different color there. I apologize. We also got to have a look that at any point in time, you want to figure out 3 bits of properties of a substance. You're going to probably get the mass. You can always work out what big M is, and that's the molar mass. Okay, molar mass, how much 1 mole of that particular substance weighs, and then you need to find out this N. As long as you find out N, the number of moles, they stay quite consistent according to this reaction here. So if I have 10 moles of salt, I will always have 10 moles of silver chloride. They will change in the same proportion. Just like if I have half a mole of salt, then I will have half a mole of silver chloride. So here, to find out our actual number of moles, we just divide the mass of sodium chloride by how much 1 mole of sodium chloride weighs, which is easy, which is, we started off with 100 grams, okay, and for every mole, it weighs 58.44 grams. So for every mole, okay. And here's the logic. Usually in exams, you don't need to put in the actual units, but I put them in anyway because then this happens, because then you can eliminate, and you should need to make sure that you've got the actual right final unit. The final unit, the grams will eliminate, and mole to the -1 when it's a denominator, it goes to the top. Okay, so this mole now becomes purple, and it ends up being 100 divided by 58, so 0.44. It should end up being around about 1.71 mole, and we know that it's mole because here we've eliminated these units here, so it ends up being mole. Let's scroll down a little bit. Okay, so now we have the number of moles. Now let's find out doing our stoichiometric ratio. So we want to find out how much of our precipitate there is, silver chloride, okay, and we want to compare that to what we do have. So what we do know is we know the number of moles of salt, sodium chloride, okay, and generally it will be, that will change in accordance to these numbers here. So what you need to do, you need to usually get the number, what the coefficient is of what we want to know about unknown, and divide it by what we already do know, which is 1/1. In this particular reaction, it's actually quite nice, so we actually end up with a really nice number, which will be just the same as this, which is 1.71 moles. Now that we have that number, we can just reverse our particular calculation to find out our weight, our mass of silver chloride, our mass of our actual white solid. So the white solid, first off, we need to find out how much 1 mole of silver chloride actually weighs, which is going to be, so this is the long way, you won't need to do this, will be the molar mass of silver added to the molar mass of chlorine, which is, I think, 107.9 grams. Oops, that's horrible, 9, I apologize. 9 grams per mole. You add that to 35.45 grams per mole, which should end up being, I believe, 143.35 grams per mole. So for every mole, okay, so let's think about this. For every mole we have, it'll weigh 143.35. Okay, so we have more than 1 mole. So logically, the mass of what we actually end up with should be more. Logically, have So our mass of our silver chloride should end up being more than 143.35. By how much more? It's just that ratio, because we have this many moles, and for one of them weighs 143.35. So we need to find out the mass. Mass is just the number of moles, how many moles we have. Okay, multiplied by how much one mole weighs. Okay, which equals, so we have 1.71 moles of our silver chloride, and one of them weighs 143.35 grams. Okay, and if you find, putting in units once again actually ends up being important. So you have 1.71 times 143.35. I'll put it in white. Our final mass should end up, if you do that calculation right now, you should end up with 245.24. Now our units here, because here you have mole to the 1. Okay, when you're multiplying, you add these exponents up. So 1 minus 1 is 0. So these two cancel out, that cancels out, that cancels out. What are we left with? G. So our final unit is grams. So we have 245.24 grams. So it's logical. Our final mass is quite logical. So this is one problem. I've got another problem up on this file. So it's this one here. In a couple of seconds, I'm going to make another video where I'm going to go through the solution. I want you to give it a go and see if you can find the answer. And I'll talk to you guys in the next video.